Now we're in lab 14, which is the equilibrium, pH, and buffer lab. In this lab, you're going to be working on multiple portions. There's 5 parts. There's parts A, B, C, D, and E to this lab. So it's basically like 5 mini labs. You can do any lab, whichever station is less crowded, you can go there. But we're going to have a sequence going down from A, B, C, and D to all the way to E. And this is the first part, which is part A, which is the saturated ammonium chloride solution experiment. So over here we have saturated ammonium chloride. So on the bottom, I'm not sure if you can see it, but there are solid crystals on the bottom that will never dissolve because this is already saturated solution. So they're going to stay there pretty much forever at the same temperature. And it's asking us, the lab instructions is asking us to half fill the test tube. So we're going to fill in only the solution part of the saturated ammonium chloride. Okay, again, this is part A. So here it is. I think this is enough. This is what ammonium chloride looks like. There's not much of a color, but here it is. Let's switch this around. Is this better?
Yeah.
All right. And we're going to have a comparison because sometimes it's good to find out what happens. So I'm going to have another test tube, which is just my control. It's just another test tube to let me have a comparison. If anything changes, if it's a subtle change, I can still see it because I'm comparing it to the original solution. So here are 2 identical ammonium chloride solutions, but we're going to do something to the first one. According to the lab manual, you are to introduce hydrochloric acid, 12 molars, very acidic, very dangerous. So we're going to start adding hydrochloric acid into this first test tube. And it says to add droplets until you see an observation, until you see a change. So let's go ahead and start adding HCl, 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 dropwise, HCl. I'm not sure if you're seeing it. Are you seeing what I'm seeing? You seeing it? I hope you see it. If you don't see it, try harder. Because it's happening, okay? Something's happening. What do you see? You see anything? Let's give it a good stir. What do you see? Okay? And what is this? What is this? To answer that question, all you need to do is just refer back to part A of this lab. That equation will let you know what this thing is, okay? And based on adding HCl to the solution, this happened. Now you are to conclude what happened. Which direction did the equilibrium shift? And how did adding HCl contribute to the shifting? You're going to be able to answer that. All right, let's move on to part B. All right, next up what we're going to do is we're going to do part B, which is the iron 3 chloride plus potassium thiocyanate solution. The procedure is asking you to make a stock solution first. After we make a stock solution, we're going to evenly distribute it to these 4 test tubes. So that's what we're going to do. We're going to mix these ingredients together. Here we have 40 milliliters of DI water, so we're going to pour that in. And then the recipe is calling for 12 drops of the potassium thiocyanate and 12 drops of this iron 3 chloride solution. So let's go ahead and count to 12 on this one. Right, 12 drops potassium thiocyanate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, there you go, 12 drops. So that's done. Next, we're going to add 12 drops of iron 3 chloride. So again, we're going to count to 12 on this one as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So here we have it. We have a solution that has both the potassium isothiocyanate and the iron here. So we're going to go ahead and get a stir bar to nicely stir it down. Looks good. And this is our stock solution. So we're going to be performing basically 3 reactions to this solution. So it's a good idea to have a stock solution and to evenly distribute it to these different test tubes. All right, so let's go ahead and distribute about 10 mils each. So I'm just going to eyeball it. As long as I have similar amounts, that'll be fine. So let's go ahead and do that. Then last but not least. So let's see if we have similar heights. I think this is good. We have more stock solution. I don't want to waste it. So let's go ahead and add some more in, right, to each test tube. And it's also a good idea, like if you're actually in a lab, to not use all of your stock solution, just in case you don't get a result, or you want to redo the experiment. At least you have still have some stock solution to prepare another test tube, so you don't have to start all over again. Anyway, so these are the 4 test tubes that we will be dealing with in part B, with the equation that's already listed. The first test tube is going to be your control. And what a control is a test tube that you already know the color, nothing's going to change, you already predict that it's going to stay this forever. And then we're going to do different things to the next 3 test tubes. If we read the procedure, test tube 2 asks you to add 20 drops of the iron 3 chloride solution. All right, so we're going to do that. Here's the iron 3 chloride solution again. We're going to add 20 drops to test tube 2. So let's go ahead and make that happen. All right, 20 drops. Let's go ahead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, that is 20 drops. And you're going to compare it with your first test tube. Let's give it a good swirl. All right, let's shake it a bit. And you make the observations. I'm not sure how well the video turns out to be, but there's probably some difference. Okay, this is test tube 2 compared to your control. Do you see any changes? If yes, write it down. What did it change from and what did it change to? Okay, that's test tube 2. All right, now let's go ahead and go to the next step. Step 3, it says using a test tube holder, place the 3rd tube, this is the 3rd tube, into boiling water until you observe a color change. So let's go ahead and do that. And since these tubes that we're using for demos are larger tubes, so it's pretty fine. It's not going to topple over, so we can just place it directly and see if you see any changes. Let's go ahead and remove the label a bit from the side. Do you see any color change? Yes or no? Okay. You can also give it a good stir, better stir, right? So everything is heated to the same temperature. Do you see anything? So again, we're going to compare it with test tube 1, which nothing happened. And do you see any differences? Is this able to show? Did it lighter, darker? You know, what happened compared to the original test tube? What happened when you placed this stock solution into high temperature, i.e. boiling water? Okay? So we're going to continue to let that run. And you're going to turn off the heat. As indicated, step 4 is turn off the heat because you already made your observations. Step 5, place the 4th tube. So now we're going to take the 4th tube and place it into a mixture of ice and water. So we're going to cool this one down. We heated the last one up. We're going to cool this one down. And we're going to make our observations. You guys ready? All right, you ready? Ready. Okay, we're ready. Okay, so let's go ahead and cool it down. Now it's really cold. And there's droplets everywhere. But I'm going to take it out so you can have a good comparison. And the video, the color change might be subtle, I hope it turns out all right. But I'm gonna lift it out and place it next to our control, okay? So are you guys ready? What do you think? Is there any visible change? And just write down what you think, okay? Just write down what you think. Is there any visible change? All right. That was test tube 4. So with that, I think it's also a good idea. I'm anticipating this to actually have a color change. So let me just take this one that was heated. You guys see this one that was heated? All right, this is the one that was heated. And then we're gonna just cool it back down and see if we can get any change. Okay, we're gonna cool it down a bit. And then let's dip it in just for fun. All right, just dip it in. See what happens. Pull the test tube down. And see if Le Chatelier's principle actually is able to predict this outcome. It's not cold enough? Really weird. Oh well. My hope is that it turns darker to a noticeable extent, but it doesn't seem too much like that. Anyway, so this is the data that we have today. We're gonna have to stick with it. So what do you say? What do you think? What do you think happened? And write your observations down and see how heat, or the absence of heat, cooling it down, might play a role in shifting the equilibrium towards the left or right. Alright, that is part B. Alright, now we're going into part C. I know part B was a little bit wacky, but that's just how it is. We'll just stick with the data we have collected and move into part C. Part C will be dealing with this compound called cobalt-2 chloride. In an aqueous solution, it's pinkish, it's a nice color. And what we're going to do is we're going to distribute 2 mils of cobalt-2 chloride into these 2 test tubes. Okay. And it says no more than 2, so we're going to abide to that. So 1 mil, 2 mils in the first test tube, and then 1 mil, 2 mils into the second test tube. It also mentions that the first test tube is a control for color comparison. So we're not going to do anything to the first test tube. We're going to do everything to the second test tube. So step 2, it says, to the second test tube, add about 2 mils of concentrated hydrochloric acid dropwise with stirring, and note the color change. So it starts out with this color, whatever you want to call this color. We're going to start adding some hydrochloric acid. Very, very concentrated, so you want to be really careful. It says with stirring. I want to make sure that you have a good idea of how this changes gradually. So add dropwise and stirring. So while I'm delivering, I'm also stirring the solution. That's 1 mil. Let's add some more. Dropwise. I'm not sure if you're seeing anything. Add some more. You're probably seeing something. So let's see if we can get it all the way to Still seeing color change as HCl drops into it. All right, so what do you see? You see it? What is this color now? You describe it on your lab manual. Describe what this color is, all right? Note the color change. And then after that, it's asking you to now drop or add DI water dropwise until the color or the original color is restored. So we're going to keep on adding DI water until it changes back to this color, okay? What color is this? You decide, and then we want to change it back to this color. So let's go ahead and drop deionized water in dropwise. See if we see any changes. Okay, let's have this. I'm going to add deionized water with the good stirring. Okay, dropwise, dropwise. Do you think this is restored? I think so. What about you? Do you think the color is back? Compare. Yeah, that's pretty close. We can add a couple more drops of DI water if we want to. Now it's back. Okay, it's back to its original color. Okay, so basically what you did is you just disrupted the equilibrium by adding HCl and disrupting it again by adding DI water. So that's what you did. So based on the results that you're seeing, you should be able to complete the rest of this page. All right, good luck.